Welcome back to the channel. I got a request to make a video about quadratics and vertex form. So in this video, I'm going to be covering everything you need to know about quadratics, vertex forms, the quadratic formula, and more. So check it out right here. Let's go. Okay, let's start with the basics. We're going to start with just factoring equations. So when you have something basic and the question just asks you for the solutions and the equation is factorable, all we need to do is factor it. So let's look at this first example. X times x plus 2 equals 8. Which of the following lists all solutions to the quadratic equation above? So first we're going to distribute it out so we can actually get it into the full standard quadratic form. So we're going to get x squared plus 2x equals 8. So x squared plus 2x minus 8 equals 0. Now we're just going to factor it. So this factors into x plus 4 times x minus 2 equals 0. So x equals negative 4 and x equals positive 2. So we know our answer is going to be C. So when you can factor it to get the solutions, just factor it and get the solutions. That's it. Now, if it gets a little more complicated, like this next one, where you have an equation that cannot be factored, well then you can't factor it. So you've got to use the quadratic formula on it. Usually the sign is that there is a value that's bigger than 1 for the first term. So the coefficient of the first term is bigger than 1. Now, of course, sometimes just because the coefficient of the first term is bigger than 1, it doesn't necessarily mean that you can't factor it. It just makes factoring a little bit more complicated. But what really gives away the fact that you have to use the quadratic formula on this is if we look at the answer choices, all of them have like a value plus or minus a radical all over something. And this looks very much like the end of the quadratic formula. So this tells us we have to use the quadratic formula. Now for the quadratic formula, there is a lovely song, which goes like this. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So again, that's x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So a is the coefficient of the term that's being squared. So in this case, 4 is going to be our a. B is the coefficient of the term that's just the variable that's not being squared. So that's going to be the 6. And c is just the constant, so that's 1. Then to solve, just substitute them right in. That's it. So we're going to do this by doing x equals negative 6 plus or minus the square root of 6 squared minus 4 times 1 all over 2 times 4. And one more thing that I failed to mention. If instead like of the original equation that they had, let's say it was something like 8v squared plus 12v plus 2. It would be useful to divide everything by 2 first, get it down to the base terms that you like where you can no longer divide it out, because then the numbers that you're going to be dealing with will be smaller, right? When you have to square something or multiply something by 4, like you're not going to be dealing with astronomically big numbers, because at the end, like those would reduce down by the end of the question, but it's just easier not to deal with them if you reduced it at the beginning. So that's what you should do. So let's simplify this down now. So x equals negative 6 plus or minus the square root of 6 squared is 36 minus 4 times 4 times 1, so the square root of 20 all over 8. Now we have to rewrite 20 in simplest radical form. So that's going to be x equals negative 6 plus or minus, let's see, the square root of 20 is the square root of 4 times 5. So take the square root of 4, so 2 root 5 all over 8, which then further simplifies into negative 3 plus or minus root 5 all over 4, which is answer choice A. So, one more time, the thing that told us that we had to use the quadratic formula as opposed to factoring it was we really couldn't factor it because like looking at the, like from the equation, it looks difficult to factor already. But then looking at the answer choices, they're all really, they're not clean, they're really dirty, gross answer choices. So when you're factoring, we're looking for, we always get clean answer choices. But since the answer choices aren't clean, that's a signal to use the quadratic formula, which isn't given to you, so I'm sorry, but you just gotta memorize that mother clucker. Graphing, which of the following could be the graph of y equals x squared plus 2x plus 2? With matching graphs to equations, for the most part, probably the easiest thing to do is just to like quickly plug in values for x and then get corresponding y values and see which graphs match up to that. There are other things you should know, the most important of which is what determines whether the parabola is going to be sad or wait, that was happy. Whether the parabola will be happy or sad. A happy parabola is one that goes like this. It opens up upwards. So that's why it's happy, like a smile, like a Joker smile. Whereas a sad, and in that case, the first term is positive. So you would have like a 3x squared if it's a happy parabola, or a 4x squared, or whatever x squared as long as the number is positive. If you have a sad parabola, it opens downwards, and you have a negative in the first term. So you might get like a negative 3x squared, or negative 5x squared, or negative whatever x squared. So you can remember that because positive people smile, and then negative people don't, they frown. Now, in this scenario, all of them really open upwards, but we could test some stuff out. And so, like in this case, we also, we know that the y-intercept is 2 because all of them cross it at 2. But let's see, what do we get when if we just plug in other numbers, like x equals 1. If x equals 1, y is going to be equal to 1 plus 2 is 3 plus 2 is 5. So basically, somewhere like a little past the origin on the x-axis, we know our number is going to be higher. So we, for example, know that the answer... Well, let's test that one more, just to make sure also. I want to really make it clear. If x equals, for example, 2, we're going to get 4 plus 4 plus 2, y equals 10. So this shows us that as x is going up, y is also going up. And it's going up pretty much at an exponential rate. So that right away, and this is as x is increasing from like 1 to higher than 1. So that it would eliminate, for example, D, and it would eliminate, for example, C as well. Cool. So that's no problem. So now we are left with A and B. Cool. So now the main difference between A and B is whether or not it crosses the x-axis. So we could quickly just test this out. Use the quadratic equation. X equals negative b, so negative 2, plus or minus the square root of b squared minus 4ac. So I'm just going to do it quickly. So that's 4 minus 4 times 1 times 2, all over 2 times 1. And now we see in the square root that we have 4 minus 8. So we're taking the square root of negative number. So when the discriminant is negative like this, right? You're taking the square root of negative number, but we can't take the square root of negative number. That means that this equation never crosses the x-axis. Because if it did, we would have had solutions. But if we're taking the square root of negative number, that means we have no solutions. So we know the answer would have to be B. And this is kind of how you graph. You're just trying to prove the graph against like the equation. Now, next topic is starting from the solution. Sometimes they'll give you part of the quadratic equation, and they'll give you a solution, and they'll ask you to get the rest of it. So for example, we have a function here. P of x is equal to x squared minus 11x plus k, and the function above k is a constant. If 2 is a 0 in the function, what is the value of k? When they say that 2 is a 0 of the function, what that means is when you plug in 2 for x, your y value or your f of x value or your p of x value, those are all synonymous, is going to be equal to 0. Because when they say something is a root, is an x-intercept, or is a 0, that all means the same thing. All that means is what is the x value when like y or the function is equal to 0. When you're factoring, that's exactly what you're doing. Because when you're factoring, you're setting the equation equal to 0 first, and then you're finding the corresponding x values for when that equation is equal to 0. So in this case, though, they gave you the 0. So what you're going to do is you're going to say 0 equals 2 squared minus 11 times 2 plus k. So 0 is equal to 4 minus 22 plus k. So 0 is equal to negative 18 plus k. So k is equal to 18. That's it. So one more time. When they tell you something is a root or a 0 or an x-intercept, that is the signal to set the equation equal to 0 and then solve it for x, or replace x with whatever value that they said is the 0 of the function. Okay, cool. Dope. Sum and product of solutions. This is the best topic because this screws everybody up, and now it will not screw you up. Congratulations, you are welcome, blessed. What is the sum of the solutions to the given equation? So first of all, like with all of these, we're going to combine like terms. We're going to move everything to one side. We're going to zero out the equation. That's always what you got to do with quadratic equations. You got to zero them out, so we're going to zero them out. Let's do it. So we're going to rewrite this as x squared minus 16x plus 39 equals 0. Now, you could factor this out, get the solutions, add them together, and I mean, a lot of times this will work. But there is a shortcut that I will now teach you. The shortcut is the sum of the solutions is equal to negative b over a. Now recall what we said negative, like what b and a were. A is the coefficient of the x squared term, so in this case it's 1. B is the oh actually, sorry, we're not going to use this original, we're going to use what we came up with. So A, so we're going to be using this equation. So A is equal to 1, B is equal to negative 16, C is equal to 39. So the sum of the solutions is equal to negative 16 over 1, so just positive 16. Now, you could, like, and to show you that this is the case, like, what would have happened if we had factored it out? Let me factor it out, like, right over here. If we had factored it out, we would have gotten, let's see, 16, 39, so x, let me see, minus 13 and minus 3, right? So our solutions would have been 13 and 3. And look what they add up to, 16. Learn this shortcut. Sum of the solutions is equal to negative b over a. Because sometimes you will get annoying quadratics that you cannot factor, and you have to use a quadratic formula if you're going to try to do them this way and get the solutions this way. But then you're spending so much time. So don't do it. Just learn this equation. There is one more equation that deals with this. So this question asked you about the sum of the solutions to the given equation. You might instead be asked about the product of the solution to the given equation. It's a similar equation. Product will be equal to C over A. Now, this is a little bit different. It's so, sum was negative B over A, product is C over A. There isn't much of a shortcut to memorize these. Just do it. Basically, just memorize them. Maybe it'll help to know that, like, the terms have to add up to the middle term, like, which is the b value, and they have to multiply out to the constant like third term, which is the c value. So maybe that'll be helpful. So if that is great, or like somebody, like one of my students came up with this once. It was like Simba, like the line from like the Lion King, like Simba. Sum is like negative b over a. I don't know. It helps some people, doesn't help others. But that's how you do. This is the shortcut for the sum and product of the solutions. Discriminant stuff. Okay, this part is really important to know. Everything here is important to know. But this is a thing people make mistakes on all the time. Let me first tell you what the discriminant is, and then we'll go into this question. The discriminant is, essentially, it's that part under the square root in your quadratic formula. So if we have, in our quadratic formula, it's x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. This part is the discriminant. Note, the discriminant isn't the square root of b squared minus 4ac. The discriminant is just b squared minus 4ac. Okay? So discriminant is b squared minus 4ac. And there's a few important rules associated with it. If b squared minus 4ac, if it's bigger than 0, you are going to have two real solutions. If b squared minus 4ac is equal to 0, you're going to have one real solution. If b squared minus 4ac is less than 0, you're going to have 0 real solutions. Now, for you smarty pants out there, you might tell me, you can have imaginary solutions, ha ha ha. We don't care about imaginary solutions for the SAT. We're only tested on real solutions. Now, let me give you a quick background, like logic lesson of where this comes from, and then we'll move forward. It should make perfect sense that if b squared minus 4ac is bigger than 0, that you would have two real solutions. And the reason is, let's say we had, negative 4 plus or minus the square root of like 6, right? Or let's make it easier. Let's say it's the square root of 36. Well, we're going to be doing a plus or minus the square root of 36. So we're going to end up doing a plus or minus 6. So when you do plus 6, we get one solution. When you do minus 6, we're going to get another solution. So that's why when b squared minus 4ac is positive, we end up with two real solutions. If b squared minus 4ac is 0, we're going to have one real solution because we're going to be adding and subtracting the same number, which is 0. And if b squared minus 4ac is less than 0, we're going to have no real solutions because if the discriminant is less than 0, that means we would be taking the square root of a negative number. And you can't take the square root of a negative number and get a real solution. So that's why there's going to be no real solutions in that case. So if that logic makes sense, great. If it doesn't, just memorize these. Cool. So in this question, they're asking, for what values of b does the equation have only one solution? And again, we're talking about just real solutions. So they're telling us the equation has only one solution. That means, for the purposes of this question, b squared minus 4ac must be equal to 0. Let's plug values in. We're looking for b, so we're just going to leave b there. So b squared, let me make that nicer, 0. Okay, so b squared minus 4. We know a is 1. We know c is 16. This has to be equal to 0. So b squared minus 64 is equal to 0. B squared has to be equal to 64. So b is equal to plus or minus 8. Boom. Okay. That's it. We're done. Now, if you want to double check yourself, basically we would just you could basically plug it back in and test it out. But we just proved that is, so I'm not going to spend time doing that, but like you could. So important factors, important lessons from this question is the discriminant. Let me give you the hint for like the signal from the question that tells you have to use the discriminant. Whenever you have a quadratic equation, and somewhere in the question they say that the equation has only one real solution, or no real solutions, or two solutions, or more than one solution, it means two solutions. Like, if they're using this language, like they're talking about the number of the solutions, and it's a question that deals with quadratics, that means that you're gonna be using the discriminant every single time. So you just have to establish whether they're looking for one solution, two solutions, or zero solutions, and then use the appropriate discriminant rule. That's it. Let's move on. We are now up to vertex stuff. So let's talk about what a vertex is first. A vertex is simply where the quadratic reaches its minimum or maximum value. The x-coordinate of the vertex is the x-coordinate of where it would be. So let me actually make a quick graph here for you to demonstrate. So like, let's say we have this graph. And let's say your quadratic function looks something like this. Your vertex is right there. Now, your x-coordinate of your vertex would be whatever this x-coordinate is. And your y-coordinate of the vertex would be whatever that y-coordinate is. It is also always going to be, I should say, the x-coordinate of the vertex is always going to be between your two zeros. So like if we, for example, know that this 0 is equal to 3 and this 0 is equal to 5, we know that the x-coordinate of this vertex is going to be 4. That's it. It has to be between the two. Alternatively, you can use a formula to calculate the x-coordinate of the vertex. The x-coordinate of the vertex is simply equal to negative b over 2a. That's it. Easy as that. And if you want to get the y-coordinate of the vertex, simply plug the x-coordinate of the vertex back into the equation, and that's all you need to do. Now the vertex could be a minimum or a maximum. Like in this graph that I showed you, the vertex is the minimum. If instead we use like this graph right here that I'm gonna make, where we've got a sad parabola, let's do it like this. The vertex would be like right there. And in that case, it's the maximum value of the parabola. So whether it's going to be a minimum value or maximum value just entirely depends on whether it's a happy parabola or a sad parabola. Cool. Yeah. So the question is, for what value of x does the function h reach its minimum value? So we could do this in two ways. One way is we know what the zeros are already, right? Because they told us we've got x minus 5 times x plus 5. That means our zeros are at x equals 5 and negative 5, which tells us that the x-coordinate of the vertex is going to be 0. That's it. Now, if we wanted to know what would be the y-coordinate of the vertex, we then just have to replace the x's with 0 and calculate it out. So like if we were to replace the x's with 0, we would have negative 5 times positive 5, so we would get negative 25. So we know the answer would be negative 25. Alternatively, what we could do is we could FOIL the x minus 5 times x plus 5 out. So that would get us x squared minus 25. And if it's x squared minus 25, we do negative b over 2a. B in this case is 0, so we know that the x-coordinate would be 0. That's it. So to get the x-coordinate of the vertex, one more time, you can use the formula negative b over 2a. Or you could get the zeros, and whatever's in the middle is the x-coordinate of the vertex. To get the y-coordinate of the vertex, you just plug the x-coordinate of the vertex back into the equation, and that's all you've got to do. And the vertex could be either the minimum value of the function or the maximum value of the function, depending on whether it's a happy parabola or a sad parabola. Let's move on. Vertex word problems. Let's do one. So you might run into a vertex word problem, which is basically just gonna be a question asking you about the minimum or maximum value. Make sure you don't confuse this with zeros, right? Like a zero of a function is where x is equal to is the value of x where y is equal to 0, but that's not necessarily going to be the lowest point of the function. So let's see what we got. Gas mileage, M of S in miles per gallon of a car traveling S miles per hour is modeled by the function below, where S is between 20 and 75. According to the model, what speed in miles per hour does the car obtains greatest gas mileage? Okay, so greatest gas mileage, greatest, we're dealing with a quadratic, so this tells us to use Vertex. So we're going to use Vertex. So we're just going to do negative b over 2a. Cool. Negative b is going to be negative 4 over 2 times negative 1 over 24. So this gets us 48. That's it. And they asked us at what speed. They didn't ask us what the actual speed. They didn't ask us what the miles per gallon would be. They didn't ask us for m. They just asked us. They asked us for s. So that's what we solved for, and that's it. Done and done. Another fun thing that appears is this, which confuses a lot of students. Let's read through this question first, and I'll show you what I'm talking about. So we've got an equation, y equals x squared minus 6x minus 16. The graph of the equation above in the xy plane is a parabola. Which of the following equivalent forms of the equation includes the x and y coordinates of the vertex as constants? This just literally, this part includes as constants, confuses people. This just literally means, which equation has the values of the x and the y coordinates of the vertex. That's it. Simple, right? So x coordinate of the vertex is going to be negative b over a, or 2a. So this is going to be 6 over 1. So this is going to be equal to, 6 over 2. So this is going to be equal to 3. So just which one has a constant of 3 in it? We don't even have to go anywhere. It's going to be a. But if you're not sure, maybe you're like, I want to just double check. Plug the 3 in back to get the y coordinate. If we plug it in, we're going to have y equals 3 squared minus 6 times 3 minus 16. So 9 minus 18 minus 16, which equals negative 25. And look, we had that negative 25 in A, so that's going to be it. They didn't have to ask us about, the vertexes constant. They could have asked us also even which of the following has the zeros of the functions as constants. In which case, you would just factor it, get the zeros, and pick the answer choice that literally has those values in the answer choice. It really is that easy. Okay, and the last couple things I want to go over, vertex form and factors. So let's talk about vertex form. Vertex form is actually, in this previous question, answer choice A is vertex form. Vertex form is simply another way of writing a quadratic. Because you could write a quadratic in standard form. Standard form would have been what we were seeing, y equals 2x squared plus 5x plus 6 is standard form. What we've got here is what's known as the vertex form. Vertex form will be written as y, we're using algebra. Vertex form is going to be y equals a times x minus h squared plus k. So in this case, let me tell you what everything means. A basically will determine whether your parabola is going to be a happy parabola or a sad parabola. If A is positive, it'll be a happy parabola. If A is negative, it's going to be a sad parabola. For the most part, this is all you really need to know about A for this test. So A determines sad, if sad or happy parabola. H is the x-coordinate of the vertex. And K is the y-coordinate of vertex. Cool. Cool. Yeah. Cool. So in this example in the previous one, where we had y equals x minus 3 squared minus 25, A would have been 1. The x-coordinate of the vertex would have been 3, positive 3. And the y-coordinate of the vertex would have been negative 25. To be honest, for pretty much, you don't really need to memorize the vertex form, to be perfectly honest. It could appear, for the most part, you just need to be able to interpret it. If you can interpret it and get it, you're good. You're gonna be good to go for pretty much any questions that deal with it. Cool. So that's a vertex form. And now factors. I bring this up as a little thing because this appears sometimes. So let's, for example, let me give you a regular quadratic. Let's say we have x squared plus, or y equals x squared plus 5x plus 6. And let's say you want to factor it. So we're going to do 0 equals x squared plus 5x plus 6. So 0 is equal to x plus 2 times x plus 3. So x is going to be equal to negative 2 and x is going to be equal to negative 3. The negative 2 and the negative 3 are the roots slash the zeros slash the x-intercepts of the function. Cool. This part, x plus 2 and x plus 3, these are the factors. So important distinction, because you might have a question that asks you something about the factors. The factors are this portion, okay? So the solutions are the x equals negative 2 and x equals negative 3. The factors are x plus 2 and x plus 3. Cool. And that's basically it. Thanks for watching the video. If you liked it, please smash the like button below, subscribe, hit the notification bell, share it with your friends and colleagues. If you have anything that you would like me to post about, leave it in the comments below and I will do so just like I did with this video. I will see y'all next time.